Assalamu alaikum wa rahmatullah. This video we will be doing question 1 from the coverage for grade 12 elite for term 2. So the first suggested question says at time t between 0 and 2 pi, the position of a particle moving along a path in the xy plane is given by the parametric equations x equals e to the power of t times sine of t and y equals e to the power of t cos of t. Find the slope of the path of the particle at t equals pi over 2. So to find the slope means dy over dx. So this is part A. So part A, the slope, which is dy over dx, equals dy over dt all over dx over dt. So dy over dt, this one here. So dy over dt, to find it, it's a product between two functions. So we will apply the product rule. The product rule says differentiate the first, leave the second, plus leave the first, differentiate the second. The derivative of cos is negative sine of t. Negative sine of t. And it will be the same for dx over dt. Okay, so let's write them here. So this is e to the power of t cos of t minus e to the power of t sine of t. And dx over dt will be similar. So it's a product rule. So differentiate the first, leave the second, plus leave the first, differentiate the second. So this is dy over dx, but we need to plug in now pi over 2. So if we plug in pi over 2, so this is e to the power of pi over 2 cos of pi over 2 minus e to the power of pi over 2 sine of pi over 2 all over e to the power of pi over 2 and then sine of pi over 2 plus e to the power of pi over 2 cos of pi over 2. So this is simple because this is going to be cos of pi over 2 is 0, cos of pi over 2 is 0, sine of pi over 2 is 1, sine of pi over 2 is 1. So it will be negative e to the power of pi over 2 over e to the power of pi over 2, which is equal to negative 1. So the slope of the path at t equals pi over 2 equals negative 1. So part B says find the speed of the particle when t equals 1. The speed is given by square root of dx over dt all squared plus dy over dt all squared. So we need to find dx over dt and dy over dt when t is equal to 1. So for part B, the speed equals square root of, we just found them in part A. So this is e to the power of 1 sine of 1 plus e to the power of 1 cos of 1. This is all squared plus what I have written is dx over dt at t equals 1. And then e to the power of 1 cos of 1 minus e to the power of 1 sine of 1. This is all squared, and the answer should be Let me just check the file quickly. E root of 2. So this is going to be E square root of 2. This is the speed. So looking back at C find the distance traveled by the particle along the path from 0 to 1. So we need to find here the distance traveled. The distance traveled from 0 to 1 is given by the definite integral from 0 to 1 square root of dx over dt all squared plus dy over dt all squared. So let's see what we have. Dx over dt, which is, let me just scroll down a little bit. Okay, so this is going to be e to the power of t sine t plus e to the power of t cos of t all squared plus e to the power of t cos of t minus e to the power of t sine of t all squared. So we need to find what does this integral equal to. So we can do it actually manually, okay, by expanding the two brackets. So this is going to be the definite integral from 0 to 1. So the first, we have the square root. The first bracket will be e to the power of 2t, 2t sine squared of t plus 2 e to the power of 2t sine of t cos of t plus e to the power of 2t cos squared of t. What I have just written is the expansion of this amount here, because the expansion is a squared plus 2ab plus b squared. We can repeat what we have done for the other bracket. The other bracket will be e to the power of 2t cos squared of t minus 2e to the power of 2t sine of t cos of t plus e to the power of 2t and then sine squared of t dt. So here we have 2e to the power of 2t sine and cosine, and here minus 2e to the power of 2t sine, cos and sine. Okay, the remaining we have e to the power of et as a common between the four remaining terms, so we can factor it out. So this is the integral from 0 to 1. This is the square root. This is e to the power of 2t. If we factor it out, that leaves us with sine squared of t plus cos squared of t plus cos squared of t plus sine squared of t dt. So sine squared plus cos squared is 1, sine squared plus cos squared is 1. So this is 1 and this is 1, right? So the whole bracket becomes 2. So this is the integral from 0 to 1 of square root of 2e to the power of 2t dt. And we can get rid of the square root by saying this is equivalent to 0 to 1 square root of 2. So we give the square root to the 2 and we give the square root to the e to the power of 2t. It becomes e to the power of t dt. Now we can simply integrate. So this is root of 2, it's a coefficient constant. And this is e to the power of 2 of t, evaluated from 0 to 1. So this is root of 2 times e to the power of 1 minus e to the power of 0, which is root of 2 times e minus 1. This is the distance traveled from 0 to 1. Why didn't we just do it by the calculator? Because this is a non-calculator active question, and this is a preparation for the ones who are doing the actual AP exam, because sometimes you will have free response questions without a calculator. So and there are how many points on this question? There are 3 points. 1 point is and for the equation with the correct integrand and limits, yani for setting up the integral, and 1 point for simplifying equation for speed, and 1 point for the solution. Okay. I hope that was clear. Thank you.